can be more complex than it seems, given the common mistakes I regularly come across, and there are certain risks in choosing the wrong device, such as burning out your MPPT controller or damaging your batteries. To choose the right solar charger, it is essential to properly analyze the specifications of a solar panel and take into account the correct values for sizing your device. As soon as you connect two panels in series or in parallel, I often see the same mistakes. So, make sure to stay until case study number 2. In this video, we will go through several examples to cover as many cases as possible to help you. Finally, we will also answer a common question about the cable size for an MPPT controller. But before we begin, feel free to check out our electrical diagram pack in the description. Also, consider subscribing to the channel, leaving a like, and don't hesitate to ask your questions in the comments. To avoid drowning in theory, we will directly take a simple practical case to make it more engaging. Here, we have a 12-volt, 220-watt solar panel from Renogy, which we use to charge a 12-volt battery. The controller must support the maximum voltage the panel can produce, including in cold conditions. In fact, in cold conditions, the output voltage of a solar panel increases. This is due to the relationship between temperature and the behavior of photovoltaic cells. Decrease in temperature equals increase in panel voltage. Increase in temperature equals decrease in panel voltage. This is why we will apply a 20% safety margin in our future calculations. First step, checking the maximum input voltage of the charge controller. Here, the VOC, open circuit voltage of the panel, is 21.86 volts. With the safety margin, 21.86 volts times 1.20 equals 26.23 volts. So, an MPPT controller with a minimum input voltage of 30 volts is required. Second step, calculating the maximum output current of the solar controller. The MPPT here will convert the panel voltage into a voltage suitable for the battery while increasing the current intensity. The maximum power of the panel is 220 watts. The charging voltage of a 12-volt battery in bulk mode is 14.4 volts, and the MPPT output current 220 watts divided by 14.4 volts equals 15.3 amperes. Here, we could also apply a safety margin to preserve the lifespan of the MPPT. So, an MPPT controller with an output current of 20 amperes will be a perfect fit. Third step, checking the maximum supported power. The controller must, of course, be able to handle the full power of the 220-watt panel. In summary, the MPPT choice must have at least the following specifications: a minimum input voltage of 30 volts, a minimum output current of 20 amperes, a minimum supported power of 220 watts. Now let's check which models would be compatible from two different brands. Looking at the specifications of a Renogy Rover MPPT, the 20 ampere model is suitable in terms of current, power, and voltage. If we choose a model from Victron Energy, the MPPT 100 volt/20 amps model also meets all the criteria. This first case study was easy, but you will see that when connecting these same two panels in series, most people make mistakes when choosing the MPPT controller.